Everyone, Assalamualaikum. Okay, so now we're going to study the last subtopic for chapter 5, which is power. Okay, power. Okay, so your first learning outcome is define and use power. Okay, define and use power. So average power, so when they say define, you have two options. It's either you want to state it in words or you want to give the equation. Okay, so average power is defined as the work done per unit time. Okay, so what is power? So if we can do more work in a shorter amount of time, then we say we have bigger power. Okay, so for example, we have a person A. Okay, person A and person B. Okay, person A and person B. Okay, so person A and person B have to move the same box. Okay, person A and person B have to move the same box, which is 10 kg. Okay, 10 kg over a constant distance of 100 meter. Okay, they have to move the same box of 10 kg over a distance of 100 meter. So you have two person lah, person A and person B. Okay, so person A pun push the box, person B also pushes the box. Person A takes a total time of 10 seconds. Okay, but person B takes a total time of 20 seconds. Okay, so we can say person A has a higher power. Okay, the power of person A is bigger. Why? Because he can move. Okay, he make the work done. Okay, he moved the box across 100 meter more faster compared to person B, who moved the box for a distance of 100 meter but took 20 seconds. Okay, so power is defined as the work done per unit time. Okay, so if you take a shorter time to do a certain work, so your power is bigger lah. Power tool is bigger. Okay, so that's a brief explanation of an example of what power is. Okay, so for the formula, formula for power is average power equals to rate change in work over change in time. Okay, so work done per unit time. Okay, so this one here, it shows that quantity of work, how much work is done. So this is the quantity of work. Okay, so how much work is done. And this one, change in time, how much time is taken. Okay, how long or how much time is taken untuk buat work tadi tu. Okay, so change quantity of work per unit change in time. So this is the formula of power. So for power's formula, you just have to use the instantaneous power formula. Okay, and the unit for power is what? Okay, capital W. Okay, that's the unit for power. Okay, so that's the first equation for power, and we have another equation for power. Okay, so we know power is the change of work per unit time, rate of change of work. Okay, so if we insert, so we have d over dt, and we replace work with its formula, which is Fs cos theta. Okay, we replace work with its formula, which is Fs cos theta. Okay, so what you can see here, what happens is we can remove ds over dt. Okay, here you have ds. Okay, we bring out ds over dt, and in the bracket, in the bracket, we will still have f cos theta. Okay, if you remember, ds over dt, rate of change of displacement is actually equals to the velocity. Okay, rate of change of displacement actually equals to the velocity. Therefore, we have another equation. Okay, by doing that, we have another equation. So now we can replace ds with dt with v. So we have another equation, which is fv cos theta. Okay, so another equation for power equals to fv cos theta. So okay, and power equals to fv cos theta, where f is the force, v is the velocity, and theta is the angle between the force and the velocity. Okay, angle between the force and the velocity. Okay, so we can write powers. Formula is P equals to F dot V. Remember, P equals to F dot V. We can open it as FV cos theta. So this is the dot product. Okay, dot product. So power can be written as F dot V, or also power can be represented as FV cos theta. Okay, so you have two equations to calculate power. If you have the velocity, then you can use this equation. But if you don't have the velocity and you have the work, okay, then you can use the previous equation. Okay, so you have two equations to calculate power. Kita tengok apa yang soalan bagi. Based on apa yang soalan bagi tu, then we choose which equation. You don't have to remember how to derive this. You don't have to remember. Perlu ingat equation ni dan equation ini sahaja, and how to use them. And remember, the unit for power is what? Okay, so let's continue to the example 11. Okay, so example 11, it says that a 70 kg person runs up the staircase 3 meter high. Okay, mass is 70 kg, run up the staircase 3 meter high in 3.5 seconds. How much power does he develop in climbing the stairs? Okay, how much power does he develop in climbing the stairs? Okay, so this one you have to understand your concept. Okay, so the force, okay, the force done, okay, for the force to be done or for the work is equal, okay, equal to the weight to overcome. So maksudnya force yang kita beri, force yang digunakan untuk naik tangga tadi tu kena sama ataupun kena lebih daripada weight. So barulah dia boleh naik tangga itu. Okay, so the force equal to the weight to overcome the gravity. To overcome the gravity. Okay, so right now we want to calculate power. So kita guna formula power, which is power equals to work done over time. Okay, so work done against gravity. Okay, so work done against gravity, which is needs to be equal lah. So work done dia kena equal dengan force dia. Okay, work done dia kena equal dengan force dia. Force apa? Dengan the weight. Okay, so the work done is going to be Fs cos theta over T. Okay, so the force here is actually weight. So kita boleh bukakan dia kepada mg. Okay, and S is the displacement or how high he travel, and cos theta. So right now he's going up the staircase. Okay, and the force is also given to go up the staircase. Cuma force yang dia given untuk go up the staircase ni kena equal. Okay, force yang dia given to go up the staircase ni kena equal dengan mg. Okay, baru dia boleh bergerak naik atas staircase tu. Maksudnya dia kena bawa lah badan dia naik. So dia kena equal to mg. Okay, so the theta is going to be kosong lah. Force dia ke atas, displacement dia pun ke atas juga. So equals to cos theta dia 0 bahagi dengan the time, which is 3.5 seconds. Okay, so we substitute in the value. Mass dia adalah 70, G is 9.81. Okay, displacement is 3 meter, cos 0. Okay, bahagi dengan 3.5. Okay, so kita akan dapat the power needed to climb up the stairs is 588.6 watts. Okay, so orang yang boleh naik staircase lagi cepat, okay, maksudnya power dia lebih tinggi. Okay, so force yang diperlukan untuk naik staircase tu kena sama dengan force weight dia. Barulah dia boleh mengangkat badan dia naik tu. Okay, so that is the power for example 11. So let's see the next question, which is example 12. Okay, ini astronaut. An astronaut with a spacesuit mass 110 kg. Okay, this is the mass. Climbing up a hill 7.3 meters. So this is the displacement in 7.2 seconds time. Requires the astronaut to expend a power of 200 watt. So kali ni dia dah bagi dah power. Okay, sorry, dia dah bagi dah power kat kita. Is the astronaut on Earth So dia tanya kita, adakah astronaut kita on Earth? So how do we know sama ada dia adalah on Earth ataupun tidak? So we have to calculate the gravitational acceleration. Tengok nilai G yang awak dapat tu, dapat tak 9.81? Kalau dia dapat 9, kalau G kita 9.81, that means astronaut tu on Earth lah. Kalau G dia nilai yang lain, maksudnya dia bukan on Earth. Okay, so sama juga, power equals to work done over time. Okay, dan bila kita buka work punya formula, dia akan jadi Fs cos theta over time. Okay, cuma sekarang we know the power, nilai power dia adalah 200. Okay, Fs, F this untuk force. Okay, sama juga, untuk dia climb the hill, force yang dia perlukan adalah mesti sama dengan weight dia. Okay, so force yang diperlukan mesti sama dengan weight dia, barulah dia boleh membawa dirinya naik atas hill tu. Okay, so force ni is force by the weight. Okay, S is the displacement, cos sama juga dia naik hill. Okay, force dia naik hill, and also displacement dia pun ke atas juga. Okay, so theta kita adalah 0 lah. Okay, bahagi time yang diperlukan, which is 7.2 seconds. So 200 equals to force by the weight, which is mgs cos 0 bahagi dengan 7.2, dan kita boleh start masukkan nilai, equals to the mass dia adalah 110. G adalah apa yang kita nak cari, displacement dia dah bagi 7.3 meter. Okay, bahagi dengan time 7.2, so kita akan dapat G equals to, okay, gravitational acceleration yang kita dapat is 1.79 meter per second square. Okay, 1.79 meter per second square. So bila kita dapat 1.79 meter per second square, maksudnya bukan kat Earth lah. Ni bukan G untuk Earth. This is not the gravitational acceleration for Earth. So is the astronaut on Earth? So we say the astronaut, okay, the astronaut is not on Earth. Okay, is not on Earth. Okay, so this is how kita jawab soalan. So dia pusing sikit je, sama je dengan soalan atas, cuma soalan atas kita cari power. Soalan ni dia dah bagi kita power. Okay, kita nak tengok sama ada G dia G on Earth or not. Okay, so that is example number 12. Moving on to the final example, example 13. Okay, example 13. An object mass 2 kg moves with a constant speed 5 meter per second up a inclined plane. Okay, so kita lukis dulu. Bila kata inclined plane, kita lukis terus lah. So this is our inclined plane. Okay, inclined plane adalah 30 degree. Okay, inclined plane kita adalah 30 degree, and the object mass 2 kg. So kita bayangkan ni adalah kotak kita. Okay, this is our kotak. Okay, and the kotak is moving up. Okay, the kotak is moving up with a constant speed. So kali ni dia bagi kat kita speed V equals to 5.0 ms negative 1. Okay, dia bagi speed kat kita, the velocity is moving upwards. A constant frictional force is acting on the object. So kalau objek itu is moving upwards, kita tahu frictional force kita mesti ke bawah. Okay, so frictional force is here. Okay, determine the rate of work done against gravitational force. Okay, so gravitational force maksudnya disebabkan oleh work lah. So dia nak rate of work done by the gravitational force. So kita tulis dulu equation. Okay, for A, equation dia adalah, so we know power equals to rate of work done dW over dt. Okay, and equation untuk power, another equation untuk power is Fv cos theta. Okay, another equation untuk power is Fv cos theta. And force yang dia refer to right now is weight. Okay, force yang dia refer to right now is weight. So kita boleh bukakan dia sebagai mg v cos theta. Okay, so the mass of the object is 2, g is 9.81, the velocity is 5. Okay, the velocity is 5 meter per second, and cos theta. Theta is the angle between the velocity and our weight. Okay, the angle between. So kita tengok velocity kat sini, this is our weight. So kita cari angle satu-satu. Kalau kat sini is 30 degree, here is going to be 90 degree. So kat sini is going to be 60 degree. Okay, tapi sekarang yang kita nak adalah between weight and velocity. So weight kat sini, velocity kat sini. So angle between here adalah 120 degree. So kat sini is cos 120. 20. Ingat between weight and velocity. Sebab weight tu adalah force yang kita nak sekarang. So adalah 120. So when you put it into your calculator, kita akan dapat the power is negative 49.1 watt. So the reason kita dapat negative, the reason kita dapat negative, it shows that work is done by the system. Work is done by the system. Work is done by the system. So sebab tu kita dapat power yang negatif. So that is for A. So A sekarang, sebab A dia nak work done against gravitational force. Kalau B, untuk soalan B, dia nak work done, rate of work done ataupun power, rate of work done by frictional force. So sekarang F ni bukan weight dah lah, F ni adalah disebabkan oleh frictional force. FV cos theta. So frictional force, dia dah bagi nilai frictional force kita, which is 4 Newton. So we can replace force ni terus dengan frictional force. We can replace it terus, frictional force. So it's going to be 4. Velocity dia masih sama 5 cos theta. So angle between frictional force and velocity. If awak tengok frictional force ke sini, velocity awak ke sini. So sebenarnya angle between the velocity and the frictional force is 180 degree. So cos 180. So when you put it into your calculator, kita akan dapat the final answer to be negative 20 watts. So again, kita dapat nilai yang negatif. The negative is just untuk menunjukkan work is done by the system. Work is done by the system. So that one is for B. And final question C. Soalan C minta kita cari power supplied to the object. So maksudnya total lah. Tadi kita cari power disebabkan oleh weight and also disebabkan oleh frictional force. So sekarang dia nak power supplied to the object. So tadi kita cari work done by the system, so dia adalah negatif. Tapi sekarang dia nak supply to the object, so kita akan positifkan semua nilai lah. So sebenarnya total power done by the system, total power done by the system equals to power on the object. Power on the object. And power on the object sebenarnya equals to, so kita akan tambahkan lah, so kita akan ambil yang positif sahaja. So yang positif, so kita akan tambahkan 20 watts tambah dengan 49.1 watts. So kita akan dapat final answer to be 69.1 watts. So don't worry, yang negatif ni just menunjukkan work done by the system. Tapi sekarang kita tak kisah work done by the system ke work done on the system ke, kita nak total power of the object. So kita akan tambahkan, kita ambil yang positif sahaja. So that is example number 13.